Hi everybody, it's Mr. Morrissey, and today we're looking at infinite geometric series. We're going to do 5 problems as usual, and we're going to do this in 2 parts, and I don't know, looking over it doesn't look too bad, but when we get right to it, here we're going to prove the summation of an infinite geometric series. We're going to say, here it says, the sum of the series is the first term divided by 1 minus r. So if you remember from a previous, the geometric series sum, we had this. So we had the first term times 1 minus the common ratio to the n. N is the number of terms. And r was the common ratio. And it says here, if r is less than 1, or the absolute value of r is less than 1, meaning it's a fraction, a negative fraction or a positive fraction, then the sum is the first term divided by 1 minus r. If you think of it this way, r here is a fraction. So let's pretend, let's say r is equal to a half, okay? So if you have the first term times 1 minus a half to the n over 1 minus r, I could put in 1 minus a half, but I'm just going to call this 1 minus r, okay? The point is that as n goes to infinity, as n gets really, really, really big, right? Let's say you say it's this, infinity. Well, 1 minus 1/2 to the infinity, 1/2 to the infinity is a really, 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 really huge fraction that's really close to 0. So 1 minus a number that's really, 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 really close to 0 is going to be just 1 minus nothing, 1 minus 0. So really this is equal to the first term over 1 minus r. And so that's how we think about the sum of an infinite geometric series. We do the first term divided by 1 minus r. Okay. Now let's try a problem using this idea, okay? So let's go to number 2. Number 2 says find the sum of 2/3, then minus 2/9, then plus 2/27, then minus 281, plus ... going on forever. So we need to find the first term. Well, the first term is a sub 1, and that clearly is 2/3. Put that in a box. The next thing we need to find is the common ratio. So I'm not going to start by using 2/81 and 2/27. I think those numbers are harder to deal with. So I'm going to do 2/9 and 2/3. So you can see pretty clearly that the common ratio here is going to be negative because you have a negative divided by a positive. And when we multiply by the reciprocal of 2/3, it looks like we get negative 1/3 is the common ratio. Okay, so using the formula we just proved in example 1, we're going to get this. First term is 2/3. Now 1 minus a negative common ratio is 1 plus 1/3. So 1 plus 1/3 is 4/3. It looks like the sum, if you went on forever to infinity, 2/3 minus 2/9 plus 2/27 minus 2/81 plus ... and notice each time, each successive term is multiplied by negative 1/3, negative 1/3. If you kept doing that, you would get a half. for the total value, the total sum. Remember, you can pause at any time. Okay, do the next one. So write the repeating decimal as a fraction in lowest term. So 0.44444444. Alright guys, let's see. Let's break this into a infinite geometric series. The first 4, I think you'd agree, that's 4 over 10. The second 4, that's 4 over 100, 4 over 1,000, 4 over 10,000, dot, 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 keep on going forever. So this is an infinite geometric series. The first term is 4 over 10, and the common ratio, well, I might not see the common ratio right straight away, so let's figure it out. I take this second term, and I'm going to divide it by the first term. Common ratio is 1/10. That should make sense. If I multiply 4 over 10 by 1 over 10, I get 4 over 100. Multiply 4 over 100 by 1 over 10, I get 4 over 1,000. So we throw it into the formula that we proved in example 1, and we are going to get something like this. So that's 9/10. Right? This is 10 over 10 minus 1 over 10. That's 9/10. So it looks like 4/9. I am going to throw that into the nifty calculator. You know what I haven't done on these videos? Let's see if you can see this. Ready? Hey! Oh, it's not focused. Let's try 4 divided by 9. Look at that. 0.444444. So we did it right. Cool. Alright, we're going to take a break now. I'm actually recording from a remote location in B105, so I don't have any music. So this is sort of a dry one. I'll have to figure out how to incorporate music in the next lesson. Actually, here, I got something. Alright guys, have a good one.